Okay, so I'm going to go over where the volume for finding a sphere comes from, and we'll also go over an example of how you would use that for the example below. And so there's a lot of relationships amongst those shapes, but the one that we're going to focus on to kind of understand where this formula comes from is that the volume of a sphere is equal to 2/3 the volume of a cylinder. And like I said before, these two shapes have the same diameter and they have the same height. So this equation I just wrote is only true in that case. It's not just that any sphere is equal to 2/3 the volume of any cylinder, of course. It's shapes with the same dimensions, basically. So that's the one that we're going to focus on to define what the volume of a sphere is. So what I want to show, though, is just to label these parts. So for both of these, we have a height. So there's our height. And then for a sphere, if it was sitting on a table or something like that, also has a height. So this measure right here would be the height for a sphere. And then remember, for a cylinder, if you're trying to find the volume, it's base area times height. And so to find the base area, you're using the radius of the cylinder. But what I just wanted to show first is that for this one, you know, the cylinder has a diameter, which is equal to 2 radiuses. Radius would be just that half of it right there. And then a sphere also has a diameter. So right across the middle, that would be the diameter. And spheres also have radiuses. So from very center to any spot on the outside edge would be your radius. And so we're going to show how the formula for the sphere comes about by showing how if we substitute the pieces of these shapes into this relationship, that the volume of a sphere is 2/3 the volume of a cylinder, and then we simplify it, that gives us the formula for the volume of a sphere. So first what I'm going to do is I'm going to take this, and the volume of our sphere is equal to 2/3 times the volume of a cylinder. So the volume of a cylinder would be the base area times the height. Base area is pi r squared, and then the height is, well, height. And so we could say that this is 2/3 times pi times r squared times the height of that. Okay, so that's just 2/3 times the volume of the cylinder. So this part here, pi r squared times the height, that's the volume of the cylinder. If you multiply that by 2/3, you would have the volume of the sphere, those same dimensions. Now spheres, though, don't, instead of having radiuses and heights, we can actually simplify this because for a sphere, the height is equal to the diameter. Notice that I have the diameter drawn horizontally, but I could have just as easily drawn the diameter that way, and the diameter and the height are the same things. And that diameter is 2 radiuses. And so the simplifying part that I was going to show was because really all we need for the sphere is the radius, because 2 radiuses makes the diameter, and the diameter is the same thing as the height. I don't have to have these different pieces. I can actually just kind of lump them all together. So 2/3 times pi times r squared times the diameter. Instead of that, I'm going to write the radius times 2. So what I just did right there was I just took the height and replaced it with 2 radiuses, because if you look at the diameter, 2 radiuses makes the diameter, and the diameter is the height. And so now all I have is the radius. That's the only piece of the sphere that I need. So I can further lump this together a little bit. This is kind of getting ahead into some exponent stuff, the way we're going to combine these. 2/3 times pi, and I have the radius squared times the radius. So that's the radius times the radius times another radius. That's 3 radiuses. So I could write that as pi times the radius cubed. Oh, times 2. I'll leave that behind. And the last part we're going to do is actually just it's actually combining factors. If I do 2/3 times 2, I can simplify this piece right here, 2/3 times 2. So the final part, simplify this, is 2/3 times 2 would be 4/3. And that is times pi times r cubed. So there is our formula right here. Volume of a sphere is equal to 4/3 times pi times r cubed. And remember, r cubed, when we use this, r cubed, that's not radius times 3. That's the radius times the radius times the radius right there. So when we're doing that, just again, that's an exponents thing. You've probably seen some of that before, but we haven't got to the unit in 8th grade where we talk about exponents. Okay, so very last part is using this formula in order to find the volume of this sphere right here. And so with this one, we have a radius equal to 6. And that's all we need. So we know the diameter of this sphere would be 12, which is also the same thing as the height of the diameter. If it was like sitting on the floor, this huge sphere would have a height of 12 meters. So let's look at how we can find the volume of this. So the volume is equal to 4/3 times pi times the radius cubed. But I'm actually going to use a slightly different version of this. I like writing it this way just because it's easier to keep track of the operations. So 4 times pi times radius cubed divided by 3. Same thing. Because if you multiply by a fraction, you multiply the values, the other factors by the numerator, in this case 4, and divide by 3. You're going to do it the same order either way. I like this one on the right just because it's a little bit easier to use. So now I'm going to substitute in my radius. So 4 times pi times 6 cubed over 3. And 6 cubed is, so this should be 4 times pi times 6 times 6 times 6 divided by 3. So that is 4 times pi, and then 6 times 6 times 6 is 216 divided by 3, and so on and so forth. I'm just getting out my calculator. Okay, so you end up doing 4 times 3.14 times 216. That is equal to 2712.96. So I have to divide by 3. And we get 904.32 cubic meters. And so when you do the practice set below, one thing to remember is that some of these are hemispheres or half spheres. So that just means you treat it like a whole sphere, and then at the end you can just divide it by 2 or multiply it by 0.5. And then just be careful, sometimes the radius is given, sometimes the diameter is given. So if you have a diameter, remember you have to divide that by 2 before you can put it into your formula to find the volume. So good luck as you do these. Check your work using the answer key over to the right. And when you finish, kind of same as before, if you feel like you need some more practice, I'm going to put some stuff on MobyMax to practice, and a review lesson in Khan Academy of these circular solids. And so, as always, also contact me if you need any help. Hope you are all doing well.